One of the major things that we see on the mapping process is the verification of the geophysics, right? We'll never go out on a project and not suggest a verification, right? I think it's very, very important to actually be able to see the utilities.
Welcome to the BIM Heroes podcast. In this episode, we will discuss the state of subsurface underground engineering and subsurface utility modeling. Welcome, Aaron and Lera.
Hey, Cody. Thanks for having us. Name's Aaron Goldstein. We're with Universal Engineering Sciences and UES for short. Just rebranded that actually relatively earlier last year. So probably more familiar with that name now. We mainly focus on a lot of geotech, construction material testing, special inspections. And now we're offering a lot of new services, I think more so expanding into the geophysical technology side of things. And that really revolves around subsurface utility engineering. Thank you for having us today to talk about that.
So my name is Lera, and I'm a part of virtual design consulting team at UES. My main responsibilities are to create 3D models based on the survey information that Aaron provides usually, and as well as built information. Thank you for having me.
Thank you for joining. One of the things that you brought up was that transition to UES this year. Who, what, and who is UES?
Yeah, so that's a great question. So UES, originally Universal Engineering Sciences, it's a portfolio of, I think it's 25 plus companies. It's a nationwide footprint. And so traditionally we have been really spending a lot of time on the geotech engineering, construction material testing, special inspections, building sciences, and we're expanding the services that we can add to our portfolio and help our clients out, mainly trying to just solve even more problems that we find on the construction sites every single day. UES's major goal is to strive for excellence and then strive to, solve a lot of these challenging problems that we face. Specifically, I would like to say that one thing that sets UES apart is specifically that if our team members in the field run into a scenario where, let's say, a superintendent has some questions about something going on their site, maybe they didn't completely understand the geotech report, or maybe they need to consult with a structural engineer, we can just pick up our phone and call one of our team members that are involved in one of the other departments and get that professional advice right there on that spot. Typically, you would see that coming from multi subcontractors. So I think where UES really succeeds and is having just this massive portfolio of services and expertise to add to the AEC industry.
And then Lera, on your side, how does the work that you're doing with Aaron at UES and virtual design consulting, what does that consist of?
Well, usually what happens is when we get a project, Aaron goes out in the field and he surveys the area of the interest, usually where there is going to be a future construction going on. And he gives me a certain file types, and I have to process the information and turn them into either 2D plans or 3D models.
And Aaron, going back to something you were discussing, I think one of the things that people understand is civil engineering, but geotechnical engineering and what that entails and how that relates to what we're going to speak about mainly today, which is subsurface utility engineering. Just explain geotechnical engineering.
Yeah, great question. Just to add to what Lera is saying, a lot of that 3D information that Lera is modeling and helping assist, that adds into the BIM side of things. It helps with that clash detection process. And I know we'll be talking about that in a little bit, but to answer your question, geotech engineering, it's been around for a very, very long time. And really specifically what it deals with is actually determining the engineering properties of the soils and the rock that are underground. That relates on so many levels to the foundations, to the footings that we put in place, largely due to determining, the types of stress and pressures that we need to add. So, we do typically like Atterberg limits in the soils lab when our Geotech team comes out to a site and, does their actual drilling and soil sampling, things like that. That information can be very useful down the road. So you can imagine it kind of from the beginning of a process for the construction, oftentimes due diligence for an owner when they acquire a plat of land. Performing geotech engineering is kind of the first level of design that really gets involved on building the actual building from a design perspective. So that establishes what can be done with specific materials. And then further down the road, as we go into the 25%, 50%, 75% design documents, that builds off of it. So you really want to have your geotech investigation and that due diligence process taken care of correctly the first time.
And as part of that process, one of the biggest things that we run into and has always been a challenge is the utility network that is currently there or the network that has been designed to be.
Yeah, exactly. So, a lot of the time with geotech engineering, you typically have to get a third party or private utility locate. And oftentimes what we see is that geotech departments will call in a 811 ticket. 811, if you're not familiar, is a state-run organization built of third-party contractors that are hired out to perform public utility locates. So typically from the public utility main up until a meter is typically what can be located. After that point, private utility locators take over. And why this is important in geotech engineering specifically is because if you were to peel away the ground surface, you would see these interconnected webs of utilities. And it's our job to resolve that issue so that when our geotech engineering team comes out on site, we start saw cutting, coring, drilling, things like that. We don't have a utility strike. That's actually one of the major liabilities that we as geo professionals and industry professionals in the AEC and industry run into so commonly is just utility strike after utility strike. So getting it done correctly, doing that private utility locate, doing SUE, subsurface utility engineering as early as possible helps prevent, just from a risk perspective, a lot of those liabilities.
What are the traditional ways that you would go about actually collecting that information?
I think one of the main things that we see in the industry is a lot of lack of education when it comes to what we call surface-based geophysics. Geophysics are basically non-destructive techniques that we can apply to the ground and to utilities to locate utilities. There is kind of a lack of education in the industry that we see, largely stemming from the term ground penetrating radar or GPR. This technique is really great for looking for utilities. However, in the US specifically, about 50% of the soils are actually very poor for utility locating. I know we sit regionally in the Carolinas and we can only see about 5-6 feet maximum. And so there are about 4 to 5 other geophysical techniques, and I won't go too involved into them, but metal detection, radio detection, magnetometry, acoustics, things like that. These are all techniques that can be applied in the field to locate these utilities accurately. And so what we see commonly is most general contractors that we educate and many that are involved in the industry don't actually know that there's more than just GPR out there.
And then of those techniques that you're using, how does that help, let's say, a civil engineer that is in the process of trying to work through the new utility network versus what you're collecting in the subsurface?
Yeah, great question. So one of the things that we see is that civil engineering in the past has not evolved very well. Just like the AEC industry as a whole, it just hasn't evolved in 30, 40, 50 years. We have new technologies, but we're not really apt to use them unless we're very sure that we have a good case usage for them. And so what we find is that civil engineers are more willing to go and perform test pitting and potholing from the documentation that they have up front. So just pulling as-built and then taking those as-built and going straight out into the field and performing test pits, potholing, hydro excavation. And what we see is actually this is very time consuming. It can be very expensive. If you're doing, like, for example, roadway work, you're going to have to account for traffic control, saw cutting, also the excavation process and backfill process. Excuse the train also, if you can hear that. So you have to account for all these different things. So we can account for all of these different things, and what that ends up looking like is somewhere between an $8,000 and $12,000 investigation per day, right? And what this does is, in a way, kind of like geotech borings, which geotech borings have their own case usage, but test pits and potholes, they only show you information in one spot. With geophysics, you can find so much more information in between those test pits. And so as that relates to civil engineering, the main thing is that we actually want to understand not just where we're going to be putting new proposed utilities in, but we also want to know the alignments, the depths, the material types, the diameters, the routing of those existing utilities way, way, way before we even start putting a backhoe in the ground. So if we can do this earlier on and coordinate with civil engineers, and they are more accepting of the technologies that exist, I think that's the way to really solve, a lot of the conflicts that we have on the design side of things.
And what would you say the state of SUE is, or subsurface utility engineering? Some of the limitations that you might see.
So I mean, I think it's important to recognize where we started and where we are right now, and maybe the future of that. So just to give just a very short history of subsurface utility engineering, it was actually first started in the 1980s. Pre-1980s, it was pretty normal for construction projects not to account for utilities and for them to just discover them, when you start putting the backhoe in the ground, right? After that process in the 1980s, and this was really where geophysics started actually becoming applicable. We had computers and software and chips that can actually run these pieces of equipment. What you're finding is that there's kind of this approach to go from civil plan drawings to potholing, and then adding the geophysics in kind of early or late 80s, early 90s. What then happened is that a lot of the DOTs of the world, the Federal Highway Association, really kind of pioneered this idea of subsurface utility engineering, which is more or less depicting utilities based off the quality of information that you have, right? So they broke these things down into 4 different quality levels. It's a pretty common practice, which is called, or which has quality level D, C, B, and A. All those stand for really is quality level D is going to be your historical as-built information. If you can pull satellite imagery, things like that. There are new technologies today like 4M Analytics platform, which uses AI and GIS to actually give you better data sets for your as-builts for utilities. You have quality level C, where that's mainly measuring your inverts of sanitary and storm. You have quality level B, where it's going to be the geophysical effort, and quality level A, that hydrovac effort. So that got established in roughly the 90s. And then you had your first standard that was passed by the American Society of Civil Engineers, ASCE. That document is the 3802 standard. And that established, as we know it, subsurface utility engineering. There's been more documentation. The most recent document that came out was the ASCE 3822, which kind of revised a lot of the information from the 3802 standard. So that's kind of where we're sitting from a standard side of things. From a geophysics perspective, from the equipment, we've had such an expansion in what is capable I want to say 2010, having something like what's called a multi-channel GPR, which is just like a GPR unit that has multi antennas stacked right next to each other. So you get really good resolution, kind of like a CAT scan, if you will. That didn't exist pre-2010. And so what you're seeing is that as we increase our technology capabilities, as we increase the softwares and AI, a lot of this equipment that wasn't available on the market now is becoming more available. The one major limitation is really the physics of how each of these techniques work, right? GPR, for example, performs very poorly in clayey soils. Acoustics, if you have a lot of noise, like vibrations or a lot of even sound, can cause some issues there. If you're doing metal detection and there's a lot of metal, like a reinforced concrete slab, that's going to cause a lot of interference. So, that's kind of where we're at. The physics won't change. The only thing that's changing in the industry is making the systems more compact, making the signal processing just ever a bit better, and introducing better software. As we move further down the road, what we are seeing now is that people are getting into this industry, into SUE, much more. We're seeing surveyors, even civil engineering firms getting into SUE. And this is great. But one of the things that we see commonly is that there's no certification process. There's no licensure to perform SUE. Technically, if you are to perform a SUE project, you are supposed to be directed by a PE, but we're not seeing that actually for the most part. What we're seeing is, because the equipment is relatively cheap to purchase, we're seeing everybody get into this industry that's in the AEC world. And what I actually propose is that there should be some regulation on that. We don't want somebody that has 1 or 2 years of experience pushing a GPR around. That's actually more common than you would think. We see typically even people with 2 weeks of manufacturer's training being called experts in the industry. And so without that regulation, that's kind of where we are right now, is kind of having this approach where we have a lot of geophysicists, a lot of engineers solving these problems. And then we have those that are just picking up the equipment, saying that the physics can do things that they can't do. And then that translates to just giving the industry kind of a bad name. So that's where we sit.
Would you say that would be one of the gaps in the industry, is the certification, and some of the others that you might say?
Yeah, absolutely. I think the major thing that we see is that there are other countries like Australia and the UK, which have a national accreditation and a national legislation to, number one, map out utilities all across their country, but then also make it required to actually have some training that's involved. To get our PEs, our PGs, our LEED certifications, whatever it is, we have to go through extensive training, schooling. We have to pass multiple exams just to get the letters after our name to be licensed to do what we do. And so I think that's kind of the next wave. And that's definitely the gap in the US industry. There's not a lot of legislation that's been passed. There are a couple of notable organizations that exist. So there's UESI, so the Utility Engineering and Surveying Institute. One of our colleagues that I've worked with in the past, James Ansbach, one of the founders of the 3802 standard itself, is very vocal about getting legislation passed on that side of things. There is NOLCA, which is the National Utility Locating Contractors Association, and they do some accreditation. But again, these are not geophysicists that are leading this. These are utility locators that have just been around for a little while. In my opinion, you do need to have that professional guidance to actually train, certify, and administer, the examination process. So that's kind of the major gap I see.
Yeah, and then one of the things of that gap, you could see some weaknesses of the past. And one of the things that's so hard is that a lot of the GIS and records of the past are not that accurate. They just weren't combined in the right way, per se. How is that getting better with what UES is doing?
I think our major approach is that every single project that we are contracted out to do on the subsurface utility engineering side of things, I think the main approach that we utilize is, obviously, we are using sophisticated platforms that exist, using AI platforms. I've mentioned 4M, for example, is one system that we utilize. And these are great for making sure we have probably the best as-built documentation that we have. From a utility designating would be the geophysical side of things. We utilize the best equipment. We have a couple of systems that have custom sensors on them. So we're well equipped with that. But I think one of the major things that kind of sets UES strategically apart is the fact that we will open every single manhole, every single junction box, every valve cover, and get accurate measurements on that. I know of others in the industry that we don't have time to do that. It always seems like on construction projects, there's kind of a push or a rush to get information. We do things the right way, and it's as a quality control process. So that way, as we continue to work on a project or other projects, we maintain that same level of care. So that way we aren't missing things.
What would be some of the strengths and weaknesses of the current process?
Yeah, so I think the current process that exists, those different quality levels that we were speaking about just earlier, actually the geophysics is very accurate, right? The side that we're seeing that's very inaccurate is the documentation process. It's always been this situation where a civil engineer creates a drawing, the utility contractors put those utilities in the ground, and then for whatever reason, whether it's the owner, the general contractor, we get in a habit of not wanting to spend money. We all have budgets to work with. It would save everybody a lot of time to survey that data before asphalt goes over the top, before we put fill over the top of that, so that we have actually real documentation. Lera and I were just talking just a little bit ago about this. When the utility contractors are putting utilities in, if they go from say a 10-inch main to a 14-inch connector and something like that, that needs to be documented somewhere. I don't really have issues if it's just a handwritten note, just having that information somewhere documented. That's the whole point of the BIM process, to have as much documentation as we can to hand over to the owner at the end of the day. So I think there's a lot of gaps on that side of things. On the utility construction specifically side of things, utilities are becoming ever increasingly more difficult to locate. You go to a major university, you work on an infrastructure project or a wastewater treatment plant. What you're going to see is these massive utility networks that go over the top and under each other, and it becomes a nightmare for designers to work with. And when it comes to the actual locating process, there's kind of been a push to put more PVC and HDPE and non-metallic utilities in the ground, and that's okay. But when we do these things, we're not putting tracer wires in, which are wires that kind of wrap around the outside of a non-metallic pipe or even metallic pipe to be able to trace it out. There are things called marker balls, which they emit just a passive frequency that you can locate on. They typically sit just above a utility. these things are not being invested in, mainly because they cost money, right? When we're laying miles and miles of utilities, we're not really concerned about how locatable they are. We're just concerned about actually getting that service rectified and usable. So I think from that perspective, there is a major limitation in that as we keep getting deeper and deeper with these utilities and we use less metallic utilities, things are just going to become way more difficult to locate. And that's kind of been pushed onto a lot of utility locators in recent times, that we can wave a magic wand or push a cart around and actually be able to find things. So I think from a holistic view, there needs to be better documentation overall. And then we need to just put a little bit more effort into either documentation before we cover the utilities up, or better way of installing utilities.
Which leads to another great question, is that subsurface utility mapping and some of the techniques of supplemental technology that's allowing you to do that underground, but also above ground. Two of the things that come to mind for me that we've used in the past on our projects is cammering different utilities to get not just the top or the bottom of a utility, but trying to understand the characteristics of an existing utility to see if it's going to be able to be continued to use and tap onto. And then the advent of Lidar for the surface level collection and tying that into the explain maybe both of those.
Yes, great question. So one of the major things we see, I see it a lot on university campuses that we've worked on, is the idea that they've installed infrastructure to expand on. So what that looks like is, you open a pull box and they'll have empty conduit already set in place, expecting that at some point or another, they're going to be routing more electric, down the road as the campus continues to expand, right? We see this very commonly. I've been involved on so many different projects where we were actually inspecting the interior of these conduits just to make sure that they're even serviceable. Maybe over time they've been crushed or the roots have come in from trees and invaded into that surface. So we can't even use those utilities. One of the major things that we see on the mapping process is the verification of the geophysics, right? We'll never go out on a project and not suggest a verification, right? I think it's very, very important to actually be able to see the utilities. I don't think we should be Swiss cheesing a site. I think that's a poor way to use our budget. But when we do expose a utility, our recommendation always is to record the material type, the diameter, the condition of the utility. So maybe something's a metallic water main is heavily corroded. Documenting that information for the owner is very important. And that tells the owner, hey, it's heavily corroded. What level of corrosion is it? Do we need to actually get this repaired? Do we need to do a further investigation to actually see how much corrosion along this alignment needs to be replaced? That's really involved when we're collecting that data. So when we expose a utility, the idea is to get as much information from that. When it relates to the mapping process, and with geophysics specifically, that information that we collect from verification, that oftentimes is used to do what in the geophysics world we call ground truthing. So that just basically means we're comparing our geophysics to our actual exact verified results. We can apply a correction off that basis. And the same thing is, if we're looking for the depth to bedrock, we do the same exact process. So that's a very common approach. So, typically our recommendation is to, follow that process. When we do these subsurface utility mapping efforts, typically the end result is a 2D drawing that have those different quality levels involved in them. And it's very important to understand what this means. Even though we have this in the legend, we oftentimes get asked about, why do you show things this way with all the different quality levels? Well, the main thing for an owner or a general contractor to understand is that, hey, we were able to locate this information in the field. We were able to verify it potentially with a test pitting method, right? Or, hey, we only got information from an as-built, maybe this might be a cause of concern. The whole idea, though, is it gives you a big picture of what's going on your site or facility. And then it asks you to estimate what more verification you as the general contractor or the owner needs from the design side or from RFI side of things to iron out those issues. So that's kind of the benefit there, is that it really can be used in that estimation process, but also just understanding what is and what could be out on your site.
And then going to that next piece of that is on the surface, tying that back with Lidar mobile scanning. So that you've got the surface tied in with the map.
Yeah. So, I think a couple episodes ago, Matt Bird talked about this really great. I think pre-20, I want to say 2010 or so, Lidar was extremely expensive, very tough to work with, just because it was very data rich and data heavy for computers to actually utilize. So as we've increased more and more on this hardware and technology capabilities, what we're actually starting to utilize Lidar for is not just to record information inside of buildings. Before walls go up, you could scan for the MEP and get that information recorded and modeled, include that in your BIM documentation, right? But also for utilities. Instead of looking at a 2D plan drawing, what if we could visit our site virtually, see where our utilities are at in a 3D environment, just like we would in BIM, and compare and contrast that with maybe the conditions right now. Maybe we're pulling in our future design and coordinating that clash detection process, or even taking a look at, maybe we have an LOD specifically at a specific place. This is where it is in relation to that environment that we've scanned. So if we can virtually visit our site from our computer, that saves a lot of time from the general contractor. Maybe they don't have to make an extra site visit. Same thing from the civil engineer. And certainly from the architecture perspective, we can actually convert these scans into 3D models. Not only are we giving context to the utilities, but we're giving context to the project at hand as well.
Which leads to, after the collection has occurred, you then start to do the actual modeling of that.
Yeah.
Come back to Lera to have that discussion. Once you get that information from Aaron, first and foremost, how does that get put into a model format? And then what is some of the challenges of doing that?
Well, usually I get different types of files from Aaron, and he is the person who designates the kind of utilities they are out there. The most important part of my job, I believe, is to apply the correct layers to certain utilities. So when the client looks at them, he knows how reliable the information is. Like Aaron was talking about the different quality levels that we have. I start by modeling the quality level B information. Then we look at the quality level D information that's coming from the as-builts. I add anything that wasn't recorded in the field by Aaron, and we don't know if those utilities are actually there, or there was some kind of obstacle in the field that couldn't allow for us to locate the utility. And the last part is adding quality level A information that comes from the potholing. That allows us to specify the exact diameter of the pipe and exact size of the duct bank. When everything is done, we have a full model of, it's pretty much an X-ray of the ground, We take it to, usually bring it to Navisworks by combining the point cloud with the 3D model that I usually model in Plant 3D, which I believe is a really good app for that, so that the client can see the above ground structures, such as fire hydrants and utility poles, and they can see how it ties in with the underground, which I believe is very valuable.
And then that process is continuously updated as
Exactly.
Aaron works through the collection, and then
Yes.
as new utilities are being put in.
Exactly. The main idea is to model the proposed utilities and see how it relates to the existing utilities and try to resolve any clashes prior to the construction. That's our absolutely main goal, is to not have any clashes in the field and resolve them during the design process of the project.
And is it one of those things that within the modeling process, there's a lot of different universities or different bodies that require us to have certain separation between different utilities? Is there something in the industry that allows you to go through that to make sure that there is that separation in the modeling process? Or is that more still manual?
So yes, there should be separation between the utilities, and what we see now, I think those separations are not always happening, unfortunately, especially when it comes to the existing utilities and depending on how congested the area is. When we see that there is not enough separation, we make a suggestion to create a gap between the utility so that the minimal requirement is there. And I think it's a process that we definitely need to work on. It's something that needs to be improved. Absolutely.
Yeah, and one of the other things that comes to mind with this is the different softwares that are being developed.
Exactly.
We talked about, Aaron, there's not that much that has changed in certain things in civil engineering. And one of the things is the modeling softwares that are used to actually model. What comes to mind right now, and both of you can weigh in on others, would be Autodesk Civil 3D or maybe Revit. Plant 3D sounds like something that's could be the future of it. But just explain where that is, the modeling softwares that are being used.
I mostly work with Plant 3D because they have a library of pipes that I can use to actually model the fittings and route the piping along any kind of grade. And I think it's the integration of multiple softwares, such as Civil 3D, that allows us to view the aerial. I also actually use Excel a lot because we get the points and elevations in Excel format. And it's just about bringing everything together and using the best parts of the software and trying to combine them into one. Because sometimes some of the clients, they have Revit models and they want to see what underground utilities model is going to look like in Revit. And then we have issues by bringing Plant 3D model into Revit because Revit doesn't know how to read those objects, right? So that, I think, is a big problem that we need to face. Right now, we have Navisworks that brings everything together, but as well, there are some limitations to it. The first time I saw Revisto when I was working with you, Cody, and I think that's it's a great software to be used because it allows us to store all the models together, and we can send the RFIs automatically to the subcontractors, which I think is one of the most important things, is to have everybody on one page, right? So what the issues are in the field, how we need to resolve them, and so that everybody knows what's going on with the project.
Yeah, and that's the collaboration side of our industry. We've always had an industry that has to be one of the largest teamwork industries because there's so many different people doing so many different things. And what they're doing with that product, I think, will help us in the long run. Now, what would you say the state of subsurface information modeling or subsurface underground modeling? Mm-hmm. What do you think the state of that is? And where are we going, and maybe how are they different?
A couple things on that. So I think one main thing is that UES has a specific way about collecting data with what we call a subsurface information model. And so the idea behind a subsurface information model is not only to just have the 3D data that we can work with, right? A lot of the time, all the data that we have is 2D civil engineering, like existing condition survey or a ALTA survey from a surveyor. So, the first thing is Well, we want to get the accurate information below ground into, well, we just want to get that information to begin with. But then if we're going to be working in a BIM perspective, then yeah, we need to have that into a 3D model at the very least. The whole idea behind a SIM or subsurface information model is that we want to actually include a lot more information with those assets. There's a lot that you can actually use these SIM, what we call SIM model, for, and it kind of varies from client to client, right? So for you and many other BIM professionals, we're using this data just to coordinate with the clash detection effort, right? So that's one of the major usages. But you could actually take these models into like softwares like Aviva, I think Cintu, and a couple others that exist out there. And let's say you're a oil refinery or chemical plant or something like that. What you can actually do is you can take these 3D models, not just the above ground, but the meshed below ground side. So that's what we call a total asset model or a digital twin. You can send these through these softwares. And now what you can do is you can add IoT devices. You can add AI to some of it. You can start tagging your P and ID information. So very useful for facility managers, right? But the whole point is that these SIM models become smart models. They're not just being used as documentation, but actually being used to output real-time information, just like, Evercam does on their sites. They're putting out information about the weather, right? They're putting, forecasting information. They're documenting everything live as it's going on throughout the process. And the same thing is going on in a smart model as well. There's all these different numbers that engineers have to pay really close attention to, make sure things are within well-accepted values. And it allows members to actually diagnose if there's maybe a leak in a system or something like that. So that's kind of where we sit right now. I think the future, and it's already starting to happen in various parts of the AEC industry, but the future is really accepting, I think, augmented reality. Right. There's some really great tools out there. Our preferred tool is VGIS. They tend to be the outperformer out of the pack. One of the things that I'll say with VGIS and the systems that we utilize is you don't have to be a surveyor. You don't have to be a superintendent. You can be a technician and pull out your phone or a tablet and actually just see this information displayed. It doesn't have to just be utility information. It can be even your design documentation. So maybe if you have a cut and fill that you're working with, you can actually see where that grade is supposed to be at, right? Where that cut and fill slope should be. As we continue to invest into the future, which in my mind is augmented reality, AI, IoT devices on our sites. Right now, we're using some IoT, like vibration monitors, for example, in real time, just to diagnose, make sure things are going well on the construction site. As we increase our technology usage, I think what we're going to see is that these problems that we run into with design, problems that we run into with safety on a construction site, same thing with potentially your appetite for risk on a site. I think what we're going to see as we harbor this new technology is that we're going to see safety increase quite a bit. A lot of that risk decreases. And I think we're just going to have a lot more information to output to the overall owner of these facilities, these buildings that we're actually constructing. So I think that's kind of where we're at.
I think that's what's so unique is that we've done a really good job on the planning aspect. Now we're starting to get into the technology that's being used to bring this to the field, like VGIS. And then in the long term, it's that final as-built that, going forward, we're going to be a whole lot better than we were 50 years ago with paper drawings. We're going to have a three-dimensional digital twin of not only the building, but also of the utility network that it's serving.
Yeah, I'd raise it even further. And, you walk into a room and see the MEP behind the walls, stuff like that. We've run into scenarios where our clients are needing to put like a new HVAC system in, and they're having to saw cut and core through concrete. They may have a lot of rebar and PT cables. Same thing if they have maybe a leaky water pipe behind a wall. If you could just output that into a augmented reality model, bring out your phone or tablet, and with a couple clicks of your finger, you output this and you can see exactly where the issue is. This is going to save a lot of time from the owner, just from a maintenance perspective. Yeah, that's the future. I mean, we have to, as professionals, kind of move the industry forward. And I think unless we're unwilling to take that risk, to trial things out, I think we're going to kind of maintain the status quo.
Yeah, and that's not just the future of their project or their university, but also the city that it's in, the state that it's in, the country that it's in. And then in general, you've got the whole world. Just like with what Google and others did with trying to map the world at a high level, this would be us all coming together to make the world a more sustainable place, where we could have a system in place that allows us to design and plan for the future.
Yeah, absolutely. I mean, I think that's kind of the goal. I think that's a big gap in the US, is just that we have all these privatized companies, like let's say Verizon and AT&T, that are unwilling to share with contractors. And I know this affects your field work and field operations, Cody. They're unwilling to share the actual routing of their facilities. If we had something in place where we had that documentation, and providers are actually willing to share that with the correct individuals, then that's going to solve a lot of problems that we're currently facing.
No doubt. And I think that's one of the things that you'll start to see more throughout as we push for this more digital twin world that we're trying to create. One of the things I wanted to mention that came up earlier is something that kind of gets us in trouble, but it's not thought about a lot when thinking about utility engineering per se. And that's the advent of looking at a geotech report and trying to understand not only where the utilities are, but where the rock and maybe where unsuitable soils might lie. We use a product called AGTEK, and it's a really good product to try to visualize the best we can. But I think there could be a lot better techniques of how to understand where that is. Where do you stand on that, Aaron?
I think this just goes for the AEC industry across the board. We are very apt to have 80-page, 90-page, 100-page reports, and some, diagrams that follow in the report, typically like geotechnical boring logs, things like that. Unless you are a geotech engineer, you're not going to understand anything that's in there. Most of the time, what we see is clients flip to the conclusions page, and that's that. Unfortunately, that's kind of been the process, and it always has been. It's not wrong. That's required. That's professional judgment that has to be given. That report is what protects professionals when we give recommendations. But what I really think that the industry could benefit from is get more in a habit of having deliverables as a kind of an end product, not a report. A report, it's kind of old and outdated. Yes, you still have to have it legally, but having a model, like say a 3D model, if you did a geotechnical investigation in a 1 acre parcel, and you did a couple of borings across that geotech or across that parcel, what you could do is just take that data, and because we know that typically geology does not have major variations over a short period, you can create a 2D map or a 3D model. That's what we want to be pushing out into the industry. If we can give you volumes of rippable material, if we can tell you also at what depth that rippable material it starts turning into non-rippable material, instead of just producing an 80-page report with a conclusion at the end of it, that's going to be beneficial to industry professionals that don't have a background in the geosciences. Same thing with civil engineers. I'm not a civil engineer. I don't speak their lingo. Same story for every professional. So if we can communicate these ideas in graphics and images, simulations, videos, deliverables, that's going to save a lot of time. And it's also going to be easier to translate that information over to a client at the end of the day.
Yeah, and I think that is something there to take a look at, you and Aaron, what they're doing on that front, AGTEK and Hexagon, where they're able to take that information from the Geotech report, and a person is inputting that information, trying to do the best we can to try to find out where that rock layer is. I think one of the things that can make that better would obviously be more, borings, as many borings as you can get. I know there's costs associated with that. But if there's a large issue with the soils, whether it be unsuitable or rock or something, we need to do more and more investigation so that we can take that information and put it into a 2D, but then turn it into 3D information. I think that's what they're trying to do with that.
Yeah, Cody, you actually bring up a really great point. So I know like the majority of this conversation has really been talking about subsurface utility engineering and how it relates to the industry. But one of the things that also in coordination with AGTEK and some of the Hexagon softwares that are out there, geophysics isn't just specifically built for utilities. It's built for, pretty much anything buried below the ground. So we actually can image bedrock. We've imaged buried boulders, like buried vehicles, things like that using geophysics. And the tolerances are relatively good. We always want to collect data, around a geotech boring. We want to have physical information, but you can actually get cross sections, like a 2D representation and even a 3D model from geophysics. And now the budgets on those can be kind of expensive depending on the area. Like, if you're working on a 100-acre plot of land, you're probably not going to save a lot of money doing a ton of geophysics. But, if you're trying to take a stab in understanding the general conditions and you want to facilitate an additional technique besides Swiss cheesing, or, doing more boreholes, you can always supplement with geophysics. And especially where we sit geologically in the Carolinas, because we have so much undulation of the bedrock. In my mind, I think that most major projects should have a seismic report and deliverable, or a resistivity deliverable. I know these aren't common terms. They may be a little bit less familiar, but these techniques exist and have existed for a very long time.
Yeah, and I think the two in our area as well is that maybe you're not doing it across the whole parcel, but you're pinpointing that there's a concern in this area.
Yep.
And the building is going to be put here, or massive utilities are going to be put in this place. You could do more investigation that's very distinct for that area to get a better idea. And I think, with what Lera is doing on the modeling piece of the utilities, bringing that data in to that world could help us in a lot of ways. And I think that's the future of taking this a step further and trying to get a better idea of that rippable material, that shot material, the blast material, or unsuitable material. And
Yeah,
really starting to do that in a lot better
absolutely.
way.
Absolutely. I think that's actually kind of the foundational idea of these subsurface information models. In my mind, what you really want to create is a BIM model, but below ground. That's why we call it SIM, right? And I think actually, that's something that the DBIA should consider being part of the BIM process. As it sits right now, subsurface utility engineering and geophysics, they are not spec'd in most projects. The only spec that we typically see is going to be on governmental projects and DOT projects. But on your traditional, we're building this commercial building, most architects and civil engineers do not put any spec in there for a subsurface utility engineering. They typically just say, was a general contractor to validate all utilities? and that's all that you're given. The same story with geophysics. That's not put into specs, and sometimes it's not necessarily required, but that's one of the major gaps that we see, is that none of this is required work. It is by the choice of the owner, the general contractor, the civil engineer. And I think that's actually where we run into a lot of these issues.
I think that's one of the biggest challenges that we face in trying to push this forward. And I think other countries, they've started with the ISO standards that are requiring a lot of that. But here in the US, there's still a large push for the civil engineering, geotechnical engineering world to join the world of architects and mechanical engineers. Because for a long, long time, they are very still stuck on the civil 3D side of things, and trying to bring that into one full practice of them modeling in 3D is going to go a long way in helping us push.
Yeah, I was just going to kind of add to that. I think earlier, Lera and I were talking about the softwares, right, that we're utilizing for modeling purposes. I mean, this is a great case study to add into Revisto or Navisworks, these softwares that allow just all these different data formats to come in. And I think that's actually one of the main things that needs to be focused on, is allowing just all data formats, regardless of whether it's OBJ or DWG or
IFC or
IFC. Yeah, it should
all
be
the terms.
Yeah, indiscriminate of the file type, to just bring in 2D, 3D assets into one single space. And I think that's the same methodology right there with geophysics for deeper applications like rock rippability, stuff like that. So I think that should be kind of the next push from a traditional geotech perspective. One thing we didn't really touch on is also, how is these softwares applicable in more of the construction material testing, special inspection side of things, right? UES is, I think, one of the main providers that is actually utilizing a lot of new technologies out there.
There's some great AI, Aaron, that I have seen. Civil AI or civilist AI is really starting to do that.
Yeah, I've heard good things about it. I need to check it out. But yeah, I mean, that's the goal of UES, is to harbor technology, to harbor these new softwares, to innovate in the field. One of the main things that we see more oftentimes than not, for example, on special inspections, and this could be just solved by maybe EverCam, right? Would be oftentimes the concrete truck shows up on site. No special inspector has been called to make a trip out to the site and do an inspection. They pour the concrete. And now what do? We don't know where the rebar is at. We don't know if it was constructed correctly. And so now we have to use either a non-destructive method like GPR or corrosion or something like that, half cell potential, or we have to core through that brand new concrete slab that we just poured, and hope that we can actually find that information. So if we had like EverCam on our sites, or if we had maybe some AI integration, augmented reality, even just having an iPad on you, using technology to record and document that information, that's what saves time. That's what helps innovate for the future. And I think that especially in those third-party testing services, there's a lot to add value to with new softwares that are on the market.
Yeah, and that's one of the things that I know that EverCam is definitely working on, their gate report and their brain system that's allowing that information to come in from the camera, tracking that process, but then trying to work with sensors from the trucks to make sure that they're meeting the different in the regards to concrete. Then we can talk about dirt movement, but in terms of concrete, making sure that the mix is correct. And then in terms of the how long the trucks sit there, how long it takes to actually pour, all those different characteristics being brought in to make sure that everything is being put in place for that purpose of testing, to make sure that we meet those tests. And then on the flip side is, dirt movement and how that dirt is being brought on and brought off, and how it's being hauled, how it's being handled. That's a whole nother aspect of it, that you take that information and then you start to take that and put together into a full report for testing. Which leads me to the final question for both of you, is final thoughts of where you feel that this part of the industry that doesn't get a lot of discussion about. It's one of those things that is kind of a forethought, but it's a major impact on project.
Yeah, I mean, I think from the utilities perspective, there's a lot of innovation from the equipment and a lot of innovation on the software side of things, but there's not a lot of major innovation when it comes to dealing specifically with technical capabilities. If you have a technician out in the field that only has a year or two of experience, you may not be getting the best information that you have. The equipment is relatively easy to purchase, relatively cheap to purchase, but to be competent and qualified to collect that data, analyze and interpret it is a whole different ballgame. I think the future, we talked about it just a little bit earlier, is really making sure that we have an accreditation program, maybe even a licensing board through the UESI, the Utility Engineering and Surveying Institute, actually have legislation passed that makes it a professional service that is reliable. And if things don't go according to plan, there needs to be documentation as to why something didn't go well. If something wasn't documented correctly, what was the reason? And ultimately, I think the main thing that it comes down to is I think there needs to be a lot of accountability on the utility locating and designating process, that there's just a big gap. I think going to 2-week training course, or you've bought a brand new equipment and then getting a 2-week or a 2-day starter session to learn how to use the equipment, that's not enough. You need years and years of experience. You need guidance from professionals, and there's just not a lot that are out there that you can depend on. So I think that's kind of the gap, and I think that's where we really need to be putting a lot of time into, is to get that infrastructure and that foundation built so that professionals can be held accountable. They are professionally licensed. Treat it just like a PE, a PG, a PLS. Treat it exactly like that. And I think what we're going to find is that utilities are going to be located much more effectively and accurately. But then I think also on the other side of things is making sure that we do have that accountability. If an engineering firm or even a person that has their license does something unethical, they can lose their license. But with utility locating, contractor hits a utility, it's either on the contractor or it's on the insurance company that the utility locator has, right?
And God forbid, the sad reality of hitting the utility, that somebody would die from that.
Yeah, exactly.
And how that would be, sanctioned out.
Yeah, exactly. So that's, in my mind, there has to be some accountability, and we see it very prevalent that there are many firms that exist and that kind of just flip around and they don't really have accountability. They can say and do what they want. And at the end of the day, if you're an engineering firm or a general contractor and you're state licensed, you have to play by the rules, right? But if you're not on that same level, then I'm sorry, you can't do anything about it. So yeah, I think the main thing is there has to be some legislation passed, I think at the national level and certainly at the state level, to help keep the industry fresh and have some QA QC involved to prevent, things like utility strikes from happening.
Yeah, and you see that a lot too on the Lidar and also on the drone front of collection of both of those. It's the same thing where it's the Wild West. I mean, anybody can go out there, and it's more expensive to buy Lidar because it's a bigger device or a more expensive device than a drone, but you're trying to collect data of the surface. And it's okay if it's for a picture format, but when we get into the survey grade type world, it absolutely has to be licensed.
Yeah, absolutely. And I see this all the time. There are firms that will advertise that they don't perform professional services, even though they are performing professional services, right? So like geology, geophysics, so pushing a GPR around, even though you may own a GPR, that's still a professional service. You are hiring somebody that had to go through training to use that system, right? That's still a professional service. Same thing with engineering, architecture, you name it. Those are professional services. And what we see commonly is that there are firms that don't and will not participate in that accreditation process. And so that's actually diluting the industry. And I think that prevents two things from happening. I think first thing is it prevents education from being distributed. Everybody wants to go do a GPR survey without understanding that GPR may not be the technique to use on a project. It's just some magical tool that can find everything. So yeah, right. So that's the first thing is that it prevents educating general contractors that are not well informed about what the capabilities and limitations are. But then I think it also dilutes the industry from actually having well-trained geophysicists and technicians, engineers that actually prevent these safety hazards from happening, like hitting a utility. God forbid fatality occurs from that. So that's really what we need, is that accountability and licensing.
And you would think from an industry that has to be highly ethical, such as ours in the AEC industry, because when you walk into a building or you drive across the bridge or you walk down a sidewalk, you don't ever feel like something's wrong. But if we ever get to that where the public mistrusts what we do, that's going to be a very dangerous world for us to walk.
Yeah, absolutely. I mean, I have my professional license to practice geology, right? And one of the very first pieces of code of ethics in that is that above all else, the safety of the public is of the utmost importance.
And we hold that in our hand.
Yes.
And that's and they trust us with that.
Yeah, it'd be the same as a medical doctor, an MD, right? Performing a medical procedure. They had to go to schooling for that. They had to get licensure. They had to do all the necessary training. I mean, years and years, 8 to 14 years of training to do all that, right? And that's also in their code of ethics, that the utmost importance is the health. We do no harm, right? And that has to be true for all professional services. And I think because we are not policing who can and should be operating pieces of equipment and interpreting, not just from geophysics, but, laser scanning, surveying, GIS, stuff like that. There has to be certification that the data that we are presenting is accurate, and also that the information that we can't record, we're at least going about it in a process that keeps the public safe. So I think it's going to take a lot of effort from UESI on the legislation side of things to push that through Congress, to make it a spec, to get some infrastructure put in place to make sure that there is regulation. So yeah, I mean, I think that's kind of my summation of that.
And then later on your front, where do you see the modeling going where could you see it getting better, and how could it become more useful?
Well, after everything we talked about, I think modeling is just a piece of this puzzle. And I'm sure it's going to get better with time. The most important thing is for anybody being able to access the model and see how it relates to the actual world. And I think it's going to happen thanks to the augmented reality, where you can just pick up your phone and scan the surface of the ground and see what's underneath. And I think this is where our future is, and I really hope it's going to happen soon. Just finding better ways of documenting the information that I think should be the responsibilities of maybe the company who puts in the new utilities to. That's something that Aaron talked a lot about, so I'm not going to repeat. But yeah, I think also bringing AI into this industry is a big step for us, as it may find better ways of doing what we're doing and bringing new ideas to how to resolve clashes, or there are so many things we can do about it. So yeah, thank you.
Yeah, and I think the big thing too for both of you is educating the next students of the world to get interested in this side of the business. Because I think that one of the things I always push to all students is the industry is vast. There are so many different avenues you can take to get into this AEC industry and really start to evolve what you really enjoy doing, which, Aaron, obviously the passion speaks true, and same with you, with Lera, but trying to get into the industry as a whole is such an important thing. I want to thank you both for joining us. And thank you for attending this episode of the BIM Heroes podcast.
Yeah, thanks, Cody.
Thank
It was
you,
a great
Cody.
time.
Thank you.